Hello guys, welcome on Tesla Adventures. In this video, we are going to discuss a extremely good concept, which is the fact that when a boy throws or drops the stones into the lake, then the level of lake falls down. I know this sounds to be other than the basic understanding, and if you are relating the thirsty crow story with this concept, we'll discuss that also. So let us start this discussion. So you can see that there is a boy whose mass is capital M along with the mass of the boat, and he is carrying some stones of mass ms on the boat. The boat and the stones along with boy are floating on the lake, and there is a marker which is attached with the walls of the lake, so we can note down the level of the liquid in the lake. And suddenly boy drops all the stones into the lake, and he notices that the lake level or the liquid level in the lake falls down. Let us discuss why. So initially, let us see that on this system, buoyancy would be acting in the upward direction and mg will be acting in the downward direction. So the buoyancy will be balancing the mg plus mg. This is m plus msg. And the value of buoyancy will be volume of liquid displaced Vd1 into density of liquid into g, and that is m plus ms into g. Cancelling g with g, so Vd1 will be equal to m plus ms divided by rho. So we can say that Vd1 will be equal to m by rho plus ms by rho. Okay, this is Vd1. In the second case, when boy drops the stone, so there would be two displaced volumes. One volume of the liquid will be displaced due to the floating boat and man. So let's suppose the total displaced volume in the second case will be Vd2, and it is the sum of Va plus Vb, where Va is the volume displaced by boat and man, and Vb is the volume displaced by sinking stones. We also know that obviously stone will sink because rho s is greater than rho l. Stone will have greater density and therefore they will sink in the liquid. And if we first of all analyze the buoyancy acting on the boy and the man, then buoyancy will be balancing out mg, and buoyancy will be equal to Va into rho into g, and that is mg. Cancelling g with g, Va will be equal to m by rho. And if we talk about the stones, we can easily say that the stone will sink down to the bottom because the density of the stones is greater than the density of the liquid, and hence the volume occupied by the stones will be their complete volume, and the volume displaced by the stones will be equal to the volume of stones. And volume of stones will be the mass of stones upon density of stones. Now the total displaced volume in the second case, Vd2, will be equal to Va plus Vb. Now if we sum Va and Vb, then it would be m by rho plus ms by rho s. And you can see that if you compare these two terms, then you can see that this is same, but in this term the denominator rho s is greater than the rho. So therefore Vd2 will be less than Vd1, and therefore level of liquid will fall definitely. But let us also discuss this, that why displaced volume affects the level of water. So let us see a situation that if there is a container and some liquid is filled in this container, and we are immersing a block. Let us suppose there is a solid in this container, and we are constantly immersing this solid deep into the liquid in the container. So we can easily say that the level of liquid will be going up in the container because this block, as it is going down, it is displacing the liquid, and the displaced liquid is increasing the level of the liquid in the container. So easily we can say that if the displaced liquid is greater, then the level of liquid in the container will go up, and if the displaced liquid is smaller, then the level of liquid in container will decrease. So obviously in this case the displaced liquid as compared to the first case is lower than the first case, and therefore we can conclude that on dropping the stones into the lake, the level of liquid in the lake will fall. Now, if you are relating this with Thirsty Crow story, so by careful observation, you can see that initially in this situation, the stones and the boy are floating on the lake, and these floating stones are being dropped into the lake, and we are comparing the level of liquid in these two situations. But in the case of that Thirsty Crow, you can see that the crow was collecting the stones from outside and he was dropping them into the water. And obviously, by dropping anything else into the liquid from outside, will definitely increase the volume of the liquid, and definitely the level of the liquid will go up. So that story is different one, and the condition and the situation in this case is different. So this was it in this video, and in the next video we'll be discussing some more concepts of buoyancy, which you will find very amazing. So stay tuned on Tesla Adventures. Thank you.